Okay, we're good. All right, so this is going to be a short video. We're only got about 27 minutes that we're going to be filming. Like I said earlier, these are questions that no calculus student has worked on before. My goal a month ago when I created this and I put these questions together was to write some really nasty, really tricky, hope you never see them on a test or a quiz kind of question, and get them in your notes as good models that you can use when you're working on the homework tonight. Tonight's homework is to finish all 14 problems. Now, before you have a total panic attack, look at the first 6. Take a look at the first 6. In the first 6, one of them comes with a hint. Yay, hints! The other 5 should be really quick for you to evaluate. Right? I would expect that everybody knows the antiderivative of 6x squared minus 3x at this point. So that's going to be like seconds. And then you're going to plug in, and yes, you are going to simplify as much as you possibly can. I want you to get the practice with the simplification. The first 6 should be relatively straightforward. Take a look at number 6, though. Have a quick conversation with the friends around you. What the heck are you going to do at number 6? Don't talk to me, talk to the neighbors. Number 6, the integral of 1 over x plus 1 plus 1 over x squared plus 1. What is that? Alright, I want to get some hands on this one. Integral 1 over x plus 1 plus 1 over x squared plus 1. How many of y'all see a part that you know what to do with? Henry sees a part that he knows what to do with. Karina sees a part. Destiny sees a part. Jose sees a part. Marilyn sees a part. Paul sees a part. Henry, what do you see?
And then the absolute value of x plus 1.
Right, integral of 1 over x plus 1 is going to be natural log of the absolute value of x plus 1. Man, I'm getting tricked into doing teenage homework assignment tonight. Okay, check. Plus, what? 1 over x squared plus 1? What the heck is that? Rubio.
Arctan of x.
That's going to be arctan of x, and then you evaluate from 0 to 1. So, not a question I've asked before. I didn't spend a lot of time with arctan. I didn't spend a lot of time with things like 1 over x plus 1. You guys have the benefit of it's time for the push. From here, you're going to plug in 1, you're going to plug in 0, you're going to subtract, and everything's going to be good. 1 through 6 are timed questions. They're really going to assess how well have you memorized the forms. What we're going to work on over the course of the next little bit is 8, 10, 12, and 14. Now, for all of my friends who are packing the super particles here, the smarticle particles, feel free to just fly. Okay? If you know what you're doing, I want you to just go, see what you can do, make me a proud papa. For all the other normal human beings, we're going to work through these and you're going to get really good notes. We're good? All right. So, number 8, the integral from 0 to 1 of 5x squared plus 8 over x plus 1. And yeah, there's a hint there. There's a hint there. Forget about the hint. Here's what I think some of you might do, and I'll just tell you that this is like wrong, wrong, wrong. Don't do it. You're going to say, oh, this is like 5x squared over x plus 8 over 1 with respect to x.
That's illegal.
Right, that is so darn illegal, it just makes me want to vomit. Right, you're not going to break up 2 terms in the top with 2 terms in the bottom as like 2 separate fractions. That's no bueno. No bueno. We're not going to do that. Other illegal things that you might be thinking about. So illegal. Oh, I've got an x down here, I've got an x up here, let those cancel. I've got a 1 down here, 1 goes into 8 times. And I'm going to get the integral from 0 to 1 of 5x plus 8 with respect to x. No, son, no. Not a thing. No matter how many times you want to try it. My advice for you instead is use your Algebra 2 skills. And you might be thinking, what Algebra 2 skills? I don't think I have them with me. 5x squared plus 8 over x plus 1. Another way to say that is 5x squared plus 8 divided by x plus 1. And we know how to divide a polynomial by another polynomial. Some of us. Okay, one way is called synthetic division, and I watched you do this last year with Mr. Link. I gotta rest his soul. 5x squared plus 8 divided by x plus 1. You would put a little number in the box. Trust me. You divide by x plus 1, negative 1 is what goes in the box. And then you list the coefficients of the polynomial going across the top. So 5x squared. Now the coefficient for the next term? The 5 is for x squared. The next term?
1.
0. 0 for the x term that is not written. And then 8 for the constant. I was there, I watched it. You would then bring down the 5. Negative 1 times 5 is negative 5. Add those together. Negative 1 times negative 5 is 5. Add those together. And synthetic division, you then interpret your answer as 5x minus 5 plus 13 divided by x plus 1.
Wait, where's...
I don't
Where'd you get it?
Put it in the box, maybe.
Okay. So that's what we call synthetic division, and apparently no one remembers that.
No.
But there might be some kids watching the video somewhere in the planet who have seen synthetic division. The other way looks something like this. You would do the big box.
Yeah.
We're starting to, maybe? Okay, you're dividing by x plus 1, so x plus 1 goes on the outside. Now your goal, 5x squared plus 8 is the numerator. The goal is to build this box so that it has an area of 5x squared plus 8. So in this top box I put 5x squared. That's the area of the box. And I bet now we know how to play the game. The area is 5x squared. The box has a height of x. What goes up here?
5x.
5x. Now what?
5x on the bottom.
5x on the bottom, Marilyn. Why?
Because,
Tell me about this box.
5x times 1.
5x times 1 is 5x. But now already I have the wrong area. I'm getting 5x squared plus 5x. I'm supposed to have 5x squared plus 8. Rubio, what are we going to do?
Minus 5.
I'm sorry, what?
I mean, negative 5. Sorry.
I'm sorry, what?
On the
My
top,
area
you
is
put
5x squared plus 5x, and you keep telling me negative 5, not negative 5.
Well, you want to cancel that out, right?
I do, but a negative 5 wouldn't cancel. A negative 5x would cancel.
Oh.
I'm that kind of picky.
Okay.
Right, these guys cancel. That's good because I don't have a middle term. So now what? Negative 5 goes on top because negative 5 times x is negative 5x. What goes down here?
Negative 5.
Negative 5. Great! That has the area that I want?
No.
No, I'm supposed to have 5x squared plus 8 as the area. What I have is 5x squared minus 5 as the area. So you need a plus 13. The plus 13 is your remainder. And so you're going to, when you write this, you're going to say, oh, so this means 5x minus 5 plus my remainder. And the way that you wrote the remainder back in like middle school was your remainder divided by what over what you're dividing by. This guy here and this guy here are the same. They're identical. So now I just need to integrate. And what I expect is that if I stop talking for 2 minutes, that you all know how to finish this off. Right? You know how to integrate all the leftover pieces. Mario, peekaboo, I see you. Okay, take 2 minutes, finish it off. Who came up with what? Box? I don't know their name.
Oh no, integrate is what you
Find that antiderivative.
You know, we drunk like
It was the.
I returned that. What problem?
I think I know whatever secret you got. When they're done, you can go Diego, when Rubio's group is done, you guys go. Gerardo, when their group is done, you go.
Oh, yeah.
Alright. Antiderivative of 5x minus 5 plus 13 over x plus 1. 5 halves x squared. Because you add 1 to the power and you divide by the new power. Integral of negative 5 is negative 5x plus the integral of 13 over x plus 1. The integral of 13 over x plus 1. This should be 13 times the natural log of x plus 1. And now you evaluate from 0 to 1. You're going to plug in, you're going to simplify, it all's going to work out okay. Okay. Alright, since I am pretty confident that everybody is fine with the plug-in part, I just want to move on. Alrighty. Let's take a look at number 10. Henry.
For, you know how it says 5x? I can put 5 over x.
If you add 1 to the exponent. The exponent is 1.
Even if you bring the 6 down, it'll be 2 plus 5 is 30.
Right, but then if you're saying that the exponent is a 6 over here, when you bring the power down, you then reduce the power by 1. You're going to have x to the 5th, not x to the 1st. Alrighty, Rue, that's number 8, and you are fine to finish from here. Alright, number 10. Another ugly kind of question that seems to involve division. Okay, yeah, division. The algebra trickery that I would recommend here, you've got one term in the denominator. Use this to your advantage. If there's just one term in the denominator, then it is totally legal to write this as x divided by 2 cubed roots of x minus x squared divided by 2 cubed roots of x with respect to x. When you just have one term in the denominator, something like this is legal and might be helpful. Why? What could you do now that you couldn't do before? What can you do? Paul sees some stuff. What about the other friends? What could you do now that maybe you couldn't do before? Jackie's got some thoughts. Marilyn's got some thoughts. Marilyn, what are your thoughts here?
Factor out the x,
What do you mean by factor out the x?
like on top.
Factor out the x that's on top. That is legal. You may find that that's not as helpful as you want it to be. Karina, what could you do?
I guess we could change the square root to
I'm sorry, not square root, but cube root?
cubic
Yep.
into negative 1/3.
Okay, I'm going to write it first as x to the 1/3, and I'm going to leave it in the denominator. I heard you say x to the negative 1/3, like you're bringing it up to the top. Okay, minus x squared over 2x to the 1/3. That's totally legal. And you're evaluating from -8 to -1. Legal for sure. Why is that helpful? What can you do now that you couldn't do before? What could you do? What do you mean by the power rule? Well, hold on, like bring the power down and reduce the power by 1 as if you're taking a derivative. We're trying to integrate. There's something I was hoping we were going to see here. X divided by x to the 1/3. What do you see? Oh, you just said it. You're dividing x divided by x to the 1/3. The algebra rule here is subtract exponents. What's the exponent here?
1.
1. I've got x to the 1 divided by x to the 1/3. X to the 1 divided by x to the 1/3 is the same as x to the 2/3 power. And then I've got that divided by 2. Minus over here, x squared divided by x to the 1/3. Those bases are the same, and I'm dividing, so I subtract. And 2 minus 1/3 is 5/3. Still dividing by 2. Still have to integrate from -8 to -1. You still have to integrate. You might want to rewrite this, and this is actually what I would do. Rather than x to the 2/3 divided by 2, it's the same as 1/2 x to the 2/3 minus 1/2 x to the 5/3, and you integrate from -8 to -1. Now I can use my power rule. And I can use my power rule over here because it's just addition and subtraction. Integral of x to the 2/3. Take 30 seconds, see if you can find that antiderivative. 1/2 x to the 2/3 minus 1/2 x to the 5/3. Check in with the folks around you if you need to. I know. I'll fix it. Power rule says add 1 to the power, divide by the new power. X to the 2/3 plus 1 is going to be x to the 5/3. To divide by 5/3 is the same as to multiply by 3/5. So we're going to get 3/10 x to the 5/3 minus x to the 5/3, add 1 to the power. You get x to the 8/3. Divide by that new power is the same as to multiply by 3/8. 1/2 times 3/8 is 3/16. And now you evaluate from -8 to -1. Plug in the -1, plug in the -8, subtract the 2. Paul.
Could you undistribute the 1/2?
Could you what?
Take out the 1/2?
Like factor out the 1/2? Because it's a constant, yes, you can factor it out in front of the integral. That's one of the things you could do. And that's going to be fine. Remember my goal? I wanted to hit some really ugly problems. Yay! Yay, my goal. This is not to break you and make you think, I can't do this anymore. I'm deliberately focused on the 4 ugliest ones. Is everybody okay with the next part with like the plug-in and the simplified? We're okay with that, so I want to skip over that part. All right. Let's take a look at number 12. What could you do with number 12? No, we're not going to give up. Ever.
Cry.
No, it's not time to cry yet. I promise. When we get there, I'll let you know.
Graduation day.
We might cry on graduation day.
Because I felt bad.
Okay. Mr. Espinosa is going to be on stage with you, though, so it's going to be weird if you don't hug him.
I'm glad shake his hand. I'm gonna go shake his hand. What was it?
Integral of dt over 5t plus 4 with respect to t.
As you would say.
Some folks know this. They're seeing the form. They're realizing that it shows up somewhere as one of the forms you need to know. There's that integral form 1 over ax plus b is 1 over a, the natural log of ax plus b plus c. This guy's in that form. If you're not seeing it yet, how about write this as 1 over 5t plus 4 dt. So this is a linear term. A is 5, B is 4. And so if you just recognize the form, you're going to get 1/5 natural log absolute value of 5t plus 4 from 1 to 4. How many guys have that as your answer? Nope, I thought I heard a couple of people say that they recognized the form, but nobody got here? Yes. Well, from here, let's finish this off. We're going to plug in the 4, so you get 1/5 the natural log 5 times 4 plus 4 is 24, minus 1/5 the natural log of, plug in the 1, 5 times 1 is 5 plus 4 is 9. That's great. That works. It's a good answer. Other things I might do to hide this from you in the middle of the multiple choice test? You guys keep saying undistribute, but the word is factor. Right, that 1/5 natural log 24 minus 1/5 natural log of 9 is good. So I could say it's 1/5 the natural log of 24 minus the natural log of 9. That works. I'm still going to hide it from you though. I'm still going to hide this from you. Natural log of 24 minus natural log of 9. There's something here. There's an Algebra 2 skill or a pre-calculus skill here. Natural log minus natural log. Daisy, what do you get?
Wouldn't it be natural log 24 divided by natural log of 9?
Not natural log of 24 divided by natural log of 9, but natural log of 24 divided by 9. So the rule, I see Karina, says natural log of A minus the natural log of B is the same as natural log A divided by B. And that's good. Yes, ma'am?
Can I ask what's the difference between like having natural log of 24 over natural log of 9? No.
It means something completely different. You're going to get a different numerical answer. Now this is good. This won't be an answer that shows up. I'm going to reduce the 24 over 9 to 8 over 3. True. And there's one more thing I'm going to do. You cannot multiply the 1/5 and the 8/3. You're taking the natural log of 8/3, but you could, that p in front of the log property, make this the natural log of 8/3 raised to the 1/5 power. One of the properties of logs is the log of something to a power. You can bring the power down. You could also bring the power back up. And if I'm really evil, do not give me 1 second. Natural log of 8/3 to the 1/5 power, I can rewrite the 1/5 power. Yeah, not square root, but the 5th root of 8/3. What is the 5th root of 8/3? I don't know. I don't need to know what the 5th root of 8/3 is. I just know that it's legal. Okay. These are uglier than what you're going to do tonight for homework, I promise. All right, we got time for one last ugly one. Let's look at number 14. Number 14, the integral from -1 to 1, e to the x plus e to the negative x, the whole thing squared, divided by e to the x. Whenever I see multiplication or division in the integrand, this is a sign to me that no good is going to happen. You have to simplify. You have to do some algebraic trickery. What algebraic trickery is out there? Have a quick conversation with somebody near you. What could you do? Okay, a lot of folks seem to be focusing on this e to the x plus e to the negative x, that you're going to square it. So you're going to maybe go to the side, e to the x, e to the negative x, e to the x, e to the negative x. Multiply it out, e to the 2x, e to the 0, e to the 0, e to the negative 2x. We did one just like this last week. So that means that my numerator is now e to the 2x, check. E to the 0 is 1. Another e to the 0 makes that 2. Plus e to the negative 2x divided by e to the x. That's good. We made some progress. We still have division. Division is bad news. Always, 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 division is going to be bad news. So what options are there to get rid of the division? Other than like just stop writing it. Legal things here. Paul, what are you thinking?
You split it up.
What do you mean split it up? What are you going to do?
E to the 2x over e to the x plus 2 over e to the x.
E to the 2x divided by e to the x plus 2 divided by e to the x plus e to the negative 2x divided by e to the x. Okay. First of all, is that legal?
Yes.
Right, if it's just one term in the denominator, that's fine. Is this better?
Yeah.
If it's better, what can you do now that you couldn't do before? E to the 2x divided by e to the x is e to the x, right? Bases are the same. So we're integrating from -1 to 1, e to the x. Oh my god, I know how to do that. 2 divided by e to the x. Better way to write that is 2e to the negative x. E to the negative 2x divided by e to the x.
Negative 3x.
Yeah, be careful with this one. E to the negative 2x divided by x. You're subtracting the exponents. That's e to the negative 3x. This one, everybody should be able to do on site. Like once you get here. So just take like 15 seconds. What's that indefinite interval going to be? Integral of e to the x is e to the x. Integral of 2e to the negative x is negative 2e to the negative x. Integral of e to the negative 3x is negative a third e to the negative 3x from -1 to 1. Plug in, subtract, simplify. This is getting picked up tomorrow. Get it done, get it done, get it done. Integration foldable today during lunch, a free 100 on the homework assignment. Thanks, Chris. The pickup was